Hello, thanks for having me, by the way. This is a beautiful city. So I am going to talk to you about the art of web authentication with Angular. A little bit about me. My name is Kim Maida. I am a Google developer expert in web technologies in Angular. I organize an Angular meetup in Ann Arbor, Michigan. And I'm also the head of developer relations at a company called Auth0. And so Auth0 is sponsoring this. Auth0 provides what we call identity as a service. So essentially, we're a cloud platform that helps you to authenticate users in your applications, as well as protect your data and your APIs. So we deal with a lot of the complexity of identity so that you don't have to, so that you can give that over to us and you can work on building your products. We're also hiring quite a bit for JavaScript folks who are good at JavaScript. So if you're interested, and we're fully remote, so you can work from basically almost everywhere in the world. So definitely check out our careers page if you're looking for something remote. So I work in identity, and when I've seen this type of thing a lot. So when people take on an authentication project or are adding it as a feature to their applications, they're usually aware that this is a pretty big thing to attempt and are rightfully quite concerned about what could potentially go wrong with this. Now, authentication and authorization standards are very clearly defined, but they're also challenging to get right. So here's the thing. You can take something like, how do I add authentication? It's hard to see, I'm sorry. How do I add authentication? And you can sort of go to Google, put it in the search box, and you can actually get to here doing the rest of the auth stuff, essentially by doing something like using an identity as a service solution like Auth0, and it really can be that easy. However, I'm going to show you a lot more of the steps that go into this today because since you're here listening to this talk, I'm going to assume that you're at least somewhat interested in sort of more of the things in between. Now, I also want to make it really clear that you don't need to know all of these steps in order to get to the end result. So you don't need to know that after you draw the circles, then you're going to sort of add the little tail, and then here's how you shade the eyes. You don't need to know all of that to get to a beautiful picture. But it does really help, so I'm going to fill you in on a lot of it today. And I'm going to start with an introduction to commonly used open standards. I'm going to go through this in what I hope is an approachable way and provide foundational knowledge on standards-based auth. I'm going to give a little bit of a backgrounder, and then I'm going to talk about how this applies to JavaScript apps and talk about ways that Angular as a platform can help you manage authentication and authorization. So I work in identity, and when I say I work in identity, or someone asks me, what do you do, and I say I work in identity, a lot of times they're going to assume that maybe I work for the government issuing government IDs, or I help people recover from identity theft or credit card fraud or something like that. That's not the case. I work in digital identity. And this actually refers specifically to a set of attributes that define an individual user in the context of a function that's delivered by a particular application. That's a lot of words, but really, as an example, so let's say that you have a online shoe retailing app. You sell shoes online. The digital identity of your users would probably be something like their credit card number, their shipping address, and maybe their purchase history, the list of the last 10 pairs of shoes they've bought. Now, another term that comes up really often in identity is authentication. And when we say authentication, what exactly do we mean by this? In a broad sense, authentication refers to the process of verifying that the user is who they say they are. Can we make sure that they're the person they claim to be? And then once we have established that we know the person is who they are, we come to this topic of authorization, which has to do with granting or denying rights to access resources. Now, when we start talking about authorization, the standard that comes up really frequently is OAuth 2.0. And the document for OAuth is really dense. I'm curious if anybody's looked at it. Has anybody ever looked at the standards for OAuth 2? Okay, so a few people. So I mentioned earlier that the standards are very clearly defined, but who writes them? Like, where do they come from in the first place? And there's a lot of different standards and organizations that deal with the internet. The one that specifically deals with OAuth is the IETF, or the Internet Engineering Task Force. This is really a large, open international community of network designers, operators, vendors, and researchers And their concern is the evolution of internet architecture and the smooth operation of the internet. Now, the technical work that's done by the IETF is done by working groups that are organized by topic. So you could have there's a security working group, there's a transport working group, so on and so forth. But to understand the actual purpose of the IETF's OAuth standards, we kind of have to go back before OAuth existed and find out, like, why were these standards written in the first place? So before OAuth 1.0 was established in December of 2007, let's say that we have our app and we want to access third-party resources, the resources of a different service. So maybe it might look something like this. Let's say that you, as a user, you use a web app called Hire Me. And you also have an account with another app called MyCal, and you use MyCal to manage your calendar events. And now let's say that Hire Me actually wants to add an event to your MyCal account. So before OAuth existed, what Hire Me would do is it would ask you, the user, for your MyCal credentials, and you would provide your credentials for MyCal to Hire Me, and then Hire Me would take your credentials and it would use your access in order to access the MyCal API on your behalf, and then it would be able to do things like call the API and create calendar events using the access that you gave it by providing your credentials. Now, this approach, this isn't a good thing, right? Sharing credentials is bad. This approach relied on one application sharing your personal credentials for a different application, and doing this is just in general not a good idea, and there's a couple of specific reasons why it should be really concerning. For one thing, if Hire Me doesn't do their due diligence to protect the credentials that you gave it for MyCal, then they really have a lot less at stake than MyCal. So if they don't protect your MyCal credentials very well and they get leaked, then Hire Me is not going to suffer that much. They're going to maybe get some bad press. Somebody's going to write a nasty blog article, and they're going to say, oh, they didn't work very hard to protect it. But it's not going to be a catastrophe, right? Also, so it would be a catastrophe for MyCal, though, because your credentials for their system have been leaked by a different system. Now, Hire Me also has way too much access to the MyCal API. Hire Me can do everything you can do because it's got your credentials. So it can read all of your calendar events, it could change your settings, it could delete events, it could do whatever it wanted in addition to adding events to your calendar. So because of this scenario, this is why OAuth came about. This is where the birthplace of the standard. Now, I'm going to specifically talk about OAuth 2.0 in this talk. And OAuth 2.0 is an open standard for performing what we call delegated authorization. Now, using OAuth, MyCal can actually delegate authorization to Hire Me to give it limited access to its APIs without incurring the risks of doing things like asking you for your MyCal credentials and having Hire Me store those credentials and use them in some way. And it does this using something that we call an authorization server. Now, this is kind of just a fancy word for a set of endpoints whose intent is to interact with the user and to issue tokens. So if we come back to our scenario with Hire Me and MyCal, only now we're using OAuth 2.0, then let's say that MyCal has one of these authorization servers. And we're going to assume that Hire Me has already registered as a known client with MyCal, so this means that MyCal is aware that Hire Me is another service that may be asking it for access to its APIs. And let's say you as a user are logged in with Hire Me already, and this is however Hire Me happens to do authentication. It's kind of outside of the scope of OAuth, and I'll talk more about that later. But Hire Me now wants to do the same thing. It wants to set a calendar event on your MyCal. So what's going to happen now is the browser's going to perform a GET request to send an authorization request to the MyCal authorization server. And then the MyCal authorization server is going to prompt you, the user, to log in with MyCal using your MyCal credentials. So you're logging in with the entity that is asking for your credentials, not like a different service. And then once the user's authenticated with MyCal, then the MyCal authorization server is going to prompt you, the user in the browser, for your consent to allow Hire Me to access the MyCal APIs to do one specific thing, to add the event, right? Because that's what Hire Me wants to do for you. And that's all it's going to say. It's going to say, will you allow Hire Me to add an event and not do anything more than that? So if you say, that's OK, I will allow this, Then the MyCal authorization server is going to send what's called an authorization code to HireMe, and it's going to use the browser to do this. And then HireMe is going to take that code and its app credentials, and it's going to send those things back to MyCal server side. MyCal at this point checks out those credentials and the code, says, OK, everything is in order. And then it's going to issue an access token to HireMe, which HireMe can use to call the MyCal API, but only within the scope of the permissions that you as the user have said that it's OK to grant to HireMe. So at this point, HireMe can use that access token to call the MyCal API to do the thing you said it could do, which was to set calendar events. Now, nothing insidious is happening anymore at this point. MyCal is asking the user to log in with MyCal. HireMe is not asking for your MyCal credentials. And HireMe can only create events. It can't do crazy things like change your settings or read all of your events. So we have the issues with sharing credentials, and the problems with giving too much access are basically gone. They've been solved by this scenario. But then the thing that happened after OAuth came on the scene was that applications wanted to do more than just call APIs. They wanted to be able to sign users in with accounts that were living in other systems. So maybe, let's say, HireMe has discovered OAuth, and they're like, oh, this is great. And they want a MyCal user to be able to log into HireMe using their MyCal account, even if they don't have a HireMe account. The thing is, OAuth 2 is for what we call delegated authorization or delegated access. It's not an authentication protocol. So there's a few problems with using OAuth 2 for authentication. If HireMe does something like take this access token, and because it has this MyCal API access token, it just assumes that that means that the user is authenticated, then what it's doing is it's assuming that the presence of the access token means that the user's authenticated with HireMe, and this causes problems. First of all, someone could have stolen this access token. We don't actually really know who it was issued for or where it came from. The token could be from a completely different user. It could have been obtained from another client that's not HireMe and then injected into HireMe. And we call this the confused deputy problem. So HireMe doesn't know where this token came from or who it was issued for. And if we think back to what I said about what is authentication, authentication is about verifying that the user is who they say they are. And HireMe just can't know this from the fact that it has this access token. So this didn't stop people from doing this anyway, though. So in order to address this, we really needed to formalize authentication on top of OAuth. And this is how the OpenID Connect specification was born. So the OpenID Foundation, like IETF for OAuth, is an organization that's responsible for essentially OpenID Connect. It's responsible for promoting it. It's responsible for, it's committed to enabling and protecting the technologies and for writing the specs. And it's a nonprofit international standardization organization. Now, again, OAuth 2 is for delegated authorization. OpenID Connect is for authentication. So if you hear somebody say, use OAuth 2 for authentication, that's actually not accurate. What you'd be using for authentication is OpenID Connect, which is a layer on top of OAuth 2. So OpenID Connect, or OIDC, as it's commonly called, is an identity layer on top of OAuth 2 for authenticating users still using the thing that we call the authorization server. And if we think back to the definition of the authorization server, we know that it issues tokens. So for authentication with OIDC, we do this with a type of token called an ID token. And the authorization server can issue ID tokens similarly to the ways that it issues access tokens, except ID tokens are not meant for the resource server, the API, they're meant for the client. They're also a fixed format that clients can parse and validate. And they parse and validate in order to extract identity information from the token and therefore be able to establish that the user is who they say they are because they've got this token that identifies them. Now, OpenID Connect as a specification extends OAuth 2 to show how to specifically issue ID tokens. Now, like I mentioned, they're a fixed format. ID tokens are the JSON Web Token format. And a JSON Web Token looks like this. It's essentially sorry. It's three string segments concatenated with periods, so it's a lot of sort of characters with dots in between. The first segment, oh my gosh. Well, the first segment is a JSON object. It's an object that contains an algorithm and a token type. And then it's base64 URL encoded so that it's URL and file name safe. The second segment is another JSON object that is base64 URL encoded. And this object has statements about the user and information about the authentication event itself. The last segment is a crypto segment, and this is a signature. So JSON Web Tokens are signed so that they can't be modified in transit. So when an authorization server issues an ID token, it's going to sign it using a key. And then when the client receives that ID token, it's going to validate the signature using a key also. Now, if we're using an asymmetric signing algorithm, then different keys are used to sign and validate the tokens. And in this case, only the authorization server holds the signing key, and so they're the only one that holds the ability to sign tokens, and then various clients will have the public key, and they'll be able to decode and validate them, but they can't create their own. They can't mint new tokens. Now, ID tokens, as per their name, provide identity information. So if we come back to that second segment, which is called the payload segment, this was the JSON object with statements about the user and the authentication event, and these are data claims. So claims, like I just said, are statements about the user and the authentication event. And if we take a look at some authentication claims, you can kind of see that. These are some of them, and I'll go through them kind of one by one, so I guess listen to what I say rather than look at this. But the first one is something called an issuer. So this is going to be the identity of your authorization server. There's also something called an audience, and this is the ID of the app that the token has been issued for. So it's the intended recipient of the token. We also have timestamps for things like expiration and the time that it was issued at, so that we can make sure that this token is within a valid window. And then finally, we have something called a nonce. And this is a cryptographically random string that binds the client to the ID token that it received from the authorization server. So essentially what happens is the client creates this random string, and when it makes an authorization request to the authorization server, it includes this nonce, this string, with the request. The authorization server then takes the nonce and it puts it inside the token in this JSON object, and then it sends it back so that the recipient of the token, the client that issued the request in the first place, can check that the nonce in the token is the same nonce that it made when it requested the token in the first place. And this is to prevent something called token injection. So if we have tokens coming from somewhere other than the authorization server, then they won't have a nonce that matches the authorization request. So we can throw those tokens out. So in addition to validating the signature using the keys, we also want to verify authentication claims, like the issuer is the token coming from the authorization server that we asked for it from. The audience, is this token intended for my application? Does it match my application ID? The timestamps to make sure it's valid, and then the nonce, which I just described. So the claims contains statements about the end user and the authentication event. So we talked about the authentication event. There are some standard claims that we can ask the authorization server to include that tell us some information about the user, so sort of the identity of the user part of the ID token. Some of them look a little bit like this. One of the most important ones is the subject, and this is a unique user identifier, so you can think of it as the user's ID. And then we can also ask for other information about the user profile claims. They could be things like their name, address, nickname, email, is the email verified, things like that. And these are all actually listed in the specification, so you can take a look at what they are. So what have we learned so far? If we go back to sort of the idea about we're sort of making this bigger picture, drawing the whole owl. We provided some background on OAuth. We talked about how OpenID Connect is a layer on top of OAuth for authentication. We talked about authorization servers, what they are, and how we issue ID tokens for if we want to deal with authentication. We talked about how the ID tokens are the JSON Web Token format. And then we talked about the different claims that are contained in the ID token. So if we pull all of this together, then we can talk about the concept of authentication specifically for JavaScript applications, because we're JavaScript application developers here. And in order to do that, I want to take a little bit of a detour to talk about cookies and server-side web applications. And I want to share how this works. So if we think about an application that is built in a server-side language, such as like PHP or .NET or something like that, then the scenario for authentication might look something more like this. So you have your browser, and then on the server, you have your back-end web application, and it might have a database. And the user's going to submit their credentials to log in. And then if the login event is successful, the server's going to set a cookie, and the cookie represents a session. At this point, the server or the app running on the server considers the user to be authenticated. Now, on subsequent requests for pages, whenever there's traffic to this domain, the cookie is attached by the browser and sent to the server. And we don't have to take any special action to make this happen. It's a browser thing. The browser will send the cookie for this domain. The server can then send down the requested page HTML and sensitive data and deliver that to the browser, and the user can look at it. Now, if the cookie expires or there is no cookie and a request is made for protected data, then the server is going to give us a 302 redirect status. And basically, this is going to tell the browser, hey, do a full page redirect so that this user can authenticate. Once that's done, then secure data can be sent again. Now, for JavaScript applications in Angular, we often use token-based authentication. And this looks a little bit different from cookie-based authentication. So if we want to take a look at tokens in single-page apps, then we have our browser. And then when the user navigates to an app, the app is actually compiled, downloaded, and it runs in the browser. We often get our data from APIs. And then let's say we have our authorization server. Now, when the user wants to log in, they're going to make that authorization request to the authorization server. The credentials are going to be verified, and then the authorization server is going to issue tokens. The tokens are then sent to the application, and the authorization server is going to set a cookie in the browser for the authorization server's domain. And what this does is it represents the user's session with the authorization server itself. The client in JavaScript is going to parse the ID token and validate it, and at this point, the browser-based application can consider the user to be authenticated. Now, when we make HTTP requests to our API, we're going to put the access token in the authorization header, and then the API is going to verify this token using middleware, and if everything checks out, it's going to send data back to the browser in the form of JSON, which the application can consume. Now, in a single-page app, though, if the page is refreshed, then the app reloads, right? So if we were putting our tokens and our user info in app memory, then it's gone. We don't have it. But what we can do is we can actually use that cookie that the authorization server set to do something called checking session. So if that session is still valid, then we're going to be able to use essentially a hidden iframe and send the authorization server cookie to the authorization server to request new tokens without ever asking the user for their credentials. And this is silent authentication. So we can do this without the user ever needing to be prompted, as long as they've got a valid cookie for the authorization server. So essentially, we can restore access and tokens even if the single-page app reloads, and we don't have to put tokens and sensitive data in something like local storage. So why don't we use cookies for single-page apps, though? Well, for one thing, cookies only work on the domain of the application. So if everything is on the same domain, like your domain has your API on it, then cookies are actually going to work in this scenario. But many single-page applications call APIs that live on other domains, or if they don't now, they might need to scale and do so in the future. And your domain's session cookie isn't going to work for the API's domain. So we could use the authorization server's cookie to check session because we were doing traffic between the authorization server. But between your application and the API's domain, then that same session cookie isn't going to work because it's cross-origin. So maybe you don't have this problem though. Maybe everything is on one domain. If you have, for example, an Angular app running on something like a .NET backend or a React app with a Node backend, and your backend serves your API and they all live under the same domain, then you can actually use cookies for this scenario. And as long as you're not exposing your API for other people to use as like a third-party API, and the API is for exclusive use of your single-page app that's running as a presentation layer, then cookies are going to work. And according to best practices, you may actually want to consider using cookies if that's your architecture and you're sure that it's not going to change. So if this is your case, then authentication with a backend that serves an API and a single-page app as a presentation layer might look something like this. You have your backend that's capable of executing code, and it's also providing API endpoints. And then the backend serves the single-page app, which is going to run in the browser, right? And then you have your authorization server. And we can use backend routes to log in, and the backend app can interact with the authorization server to authenticate users. And then the data that's moving between the backend and the single-page application can be secured with an HTTP-only session cookie. However, maybe you don't have a backend. Maybe you're going for something serverless. Maybe your APIs are on other domains. Maybe you know that you're going to need to scale and call other APIs in the future, or that you're going to provide your API to other people as a third party. Then in that case, then you do want to use tokens. Now, there's some guidance around the use of tokens in single-page applications. And in order to talk about this, we're going to talk about what's been happening for the sort of recent past that we know about. So in 2012, this was the year that the OAuth 2 spec was adopted. And single-page applications weren't mainstream yet at this point in time. So for example, AngularJS didn't actually become popular and gain a lot of traction and use until about 2014. So that didn't mean that OAuth didn't address the idea of this, though. So if you were going to make a request to authorization server, then the same endpoint that receives the authorization request used to return tokens to the browser in a URL hash fragment. And this is how we would get tokens if we were using a single-page app and an authorization server. Now, there's some security risks with doing this, though, especially for access tokens, because access tokens grant API access. If we were to think back to the problem with the confused deputy, the application doesn't actually know where these access tokens really came from. It's just assumed that if it gets an access token in this hash fragment, that it should use it and it was OK to use. So the tokens are vulnerable in a number of ways. They're vulnerable in what we call the redirect URI, which means that we could receive the token to a URL that is not supposed to go to. A malicious actor could say, hey, this token should be sent to me instead of where it's supposed to go. It's also accessible in the browser history. The browser history API is accessible to any JavaScript running on the page, right? It's accessible in the refer header. So if a malicious page was requested right after a login event, then the malicious actor could grab that token out of the refer header as well. And then finally, we have this problem of the application doesn't know if the token was injected maliciously from somewhere else. Now, authorization servers and application developers mitigate these security risks. We work pretty hard. We put in a lot of effort to do this. And I talked about strategies like for the ID token, for example, validating the signatures and verifying the claims. And I want to be really clear that there's no new threats to this approach. It's not like all of a sudden there's some new attack and everything that we've been doing for the last 7 years is a terrible idea and all of a sudden all those apps are vulnerable, because they're not. And in fact, this approach is still viable if you're only requesting ID tokens, because we validate ID tokens in the client. And we would never use ID tokens to access other resources. And also, if you have mitigated, if you have a lot of good cross-site scripting protections, and you're sort of making sure that you're validating your tokens properly, then the same mitigations you've been using for the last 7 years are going to continue to work. But Because modern JavaScript is really just sort of eating the world of web apps at this stage in time, it was just the right time for the IETF to start recommending new best practices. So in early 2019, they worked on this and did this. And so I'm going to tell you about what the new best practice is. Now, it's actually the same approach that's used in mobile apps, because mobile applications are also public clients. And essentially, it involves exchanging a code for a token. So it's a few more steps than the old process. But how this works is basically on the client, we create a random string called a code verifier. And then we use a hashing method called the code challenge method to compute another string from this code verifier. Then when the user comes along and we make an authorization request to the authorization server, we take the request, the code challenge, and the code challenge method, that hashing method, and we send these things to the authorization server's authorization endpoint. And the authorization server is going to take these things and keep track of them, and it's going to generate a code. And it's going to send the code to the browser. And the browser is going to receive this code in a URL query string. And this is actually fine to do, unlike putting the tokens in the URL, because interception of the code by itself isn't dangerous because it doesn't grant access to anything. Someone could steal this code and then they wouldn't be able to do anything with it. They wouldn't be able to get anywhere. Because once we have that code, then we're going to make another request to the authorization server. We're going to take the code and the code verifier, and we're going to send those to a different endpoint on the authorization server called the token endpoint. The authorization server is then going to calculate the code challenge from the verifier using the code challenge method. It's going to compare that calculated challenge that it just calculated itself, and it's going to compare it to the challenge that the application sent on that first pass, the initial pass. And if those challenges match, then it's going to issue tokens and deliver them to the application as a JSON object. Now, all the mitigations for the security risks that we were facing with putting the tokens in the URL are not needed anymore. So they're sort of taken care of. But this is a lot of work, right? It looks like it's a lot more things to deal with. You have to deal with hashing, and you have to deal with multiple endpoints on the authorization server and all of these things. But the great thing is that SDKs can basically take all of this and do it for you. So these new best practices, from a pragmatic sense, what do they mean for you as an application developer? Well, if you are building a brand new application and you've got a greenfield, then I strongly recommend that you use the new approach. Like I said, SDKs can really sort of alleviate the stress of needing to sort of generate the code verify yourself and dealing with the hashing and all of that type of thing. But if you have existing applications that are already running in production, again, I want to emphasize there's no new threats to how we did it for the last 7 years. There's innumerable single-page apps out there using the old approach. Everything that's been doing this for the last 7 years is using the old approach. So I would really encourage you to assess your needs and then make the choice that works best for your team, your application, your company, your client. See if what makes the most sense. If you have time and resources to re-implement and switch over to the new approach, then that's awesome. You can sort of do away with all of the mitigations. But as long as you are using those mitigations and you have something in place, if you don't have time and resources, it's not really the end of the world. So if we come back to kind of drawing this owl, we've now covered traditional web application with cookies, or web application authentication with cookies. And we've also covered single-page app auth with tokens on APIs that are on the same domain as well as cross-origin. But I want you to remember this is still only really a two-step process. It only has to be a two-step process. Only now you know a lot more about what's going on in the interim steps. So essentially, you've leveled up. And you can get started right away by using an identity as a service like Auth0. And Auth0, for example, provides a JavaScript SDK that implements the new best practices for you, and all you really have to do is configure it and throw it into your application. And then we also provide quick start tutorials with sample code so that you can quickly and easily implement this in your Angular applications. And you probably can't tell, but disasters are happening. Sorry. Okay. And so I wrote the quick start. So if you have any feedback about it or complaints about it, you can come to me with that stuff. Now this isn't working. So going to the next slide. Oh, there we go. So how does Angular as a platform help us deal with a lot of these things? And I want to cover this by using sort of a to-do list. And I don't mean we're going to like build a to-do list application or something like that. It's just these are things that we want to make sure that we cover when we're dealing with authentication in Angular. The first thing that we want to be able to do is elegantly manage authentication events. So this might be stuff like, when is the token available? What's the login status of the user? Things like that. We also need to be able to send the token with API requests. And then on the UI, we do want to probably be able to restrict access to certain routes. Now we have, let's say, we should always have our API protected, but we can't solely rely on that because we can't just make API calls and then get an error back and be like, hey, user, sorry, like you actually can't access that endpoint. We want to be able to stop them before they get to that point in the UI. So if we talk about managing authentication events, Angular has this awesome library that comes with it, which is RxJS, of course. And RxJS helps us to do things like interact with SDKs in a reactive way. So we can do things like binding callbacks or converting promises. This is especially useful if we're using external libraries, like an external JavaScript SDK from the authorization server that maybe was built for all JavaScript in general, but not specifically with Angular in mind. So maybe it's not reactive out of the box. And we can take methods from these libraries and turn them into observable streams. So for example, maybe our authentication SDK provides some kind of a callback method to return token data from the authorization server after the user logs in. What we can do is use something like bind callback or bind node callback, depending on how the SDK is constructed, from RxJS to do something like create an observable that's going to emit when the callback completes. Then we can subscribe to this observable and pass options to the bound SDK method if necessary. And if the library returns promises, then we can use the from observable creation method to convert promises to observables as well. The other thing that RxJS can really help us do is manage streams of authentication data. This could be, like I mentioned before, token availability, availability of user information, login status, is user logged in or out, when does this happen, and do I need to react to it in some way in my application? So for example, if we wanted to create a stream for user data, then we could do something like create a private behavior subject in an authentication service. And then when data becomes available or changes as a result of some kind of authentication event, then we can tell the stream to emit values. And then we can expose the user observable publicly to our application and then subscribe to it and take some action as a result of new values being emitted from this stream. Now, these are really just a couple of surface level examples of how RxJS can help us to do things like manage authentication data and callbacks. And I'm sure that you can find a lot more ways to use RxJS to help with authentication in your apps. And if you do, I would love to hear about it. So please let me know on Twitter or however. I would love to take some of those examples and maybe highlight them in future talks or something like that. So if we come back to our authentication to-do list, we learned that we can elegantly manage authentication events with RxJS. So that brings us to the topic of sending the token with API requests. And we can do this with HTTP interceptors. Now, interceptors transform requests or responses. So when we call the API, then we can intercept requests using an interceptor service. And then we can attach the authorization header with a token. And then we can send the whole request on its way. And we use interceptors by setting them up in our app routing module. So in the providers array of our ng module in our app routing module, we are going to provide the HTTP interceptors token from Angular Common. And then we're going to tell it to use an interceptor service class. And I'll talk about what the class looks like in a moment. And we can set multi to true because we can potentially define multiple interceptors. They're just going to be called in the order that they're provided. Now, that interceptor service class might look something like this. It might contain something like this. There's some necessary setup, and then inside the intercept function, we can take that HTTP request that's coming through and we can clone it. And then we can set an authorization header on that outgoing request with the value of bearer and then the access token. And then we can send the cloned request on its way with the new header attached. Now, there's not out of the box a way to only run interceptors on specific requests, but we can very easily use conditional logic to do this. So we can clone and modify requests based on some condition. So if for example, you may want to do this for security, right? Because if you want to see if your requested endpoint matches the API that we want to send the token to, because you don't want to necessarily attach tokens to every single request that's going out, especially if you are sort of victim to some kind of attack where your app can call something that it shouldn't be calling. Then we don't want to just freely give our token to every outgoing request. So we can do something like take the original HTTP request and see what its URL was, and then check for some condition. I updated some code here, which may not be accurate anymore. But we can also check for if we only want certain endpoints on our API to be secured, then we might check for a certain segment that's going to exist in the URL, and then only clone if necessary. And then if it doesn't meet the conditions that we set for it, then we can send the original HTTP request on its way without attaching any headers to it. Now, another thing we can do is create asynchronous interceptors. So we can wait for something to happen, and this is specifically useful in the scenario where you load a page and then you make API requests in the background while the page loads, but if you want some of them to be authorized, then you're going to want to wait until the token is available, so you're not trying to send requests with something like an authorization header that says bearer undefined in it. So we can use RxJS to wait until data is available before we do something like cloning the request and attaching the header. So we could do something like, with RxJS, we can set up a token stream in our authentication service, for example, and then we can ensure that the token is present in the application and set the token once it's available. So we can use something like merge map to ensure that if there are multiple requests, then none are canceled by a new request. So if we come back to our to-do list, we know we can use interceptors to send the token with API requests. And this brings us to the topic of restricting access to certain routes. And people are probably fairly familiar with route guards at this time. Route guards implement 3 different interfaces. The canActivate interface is probably just by default the most commonly used example. And it prevents unauthorized users from navigating to a particular UI route. But the thing is, the code for this route is still in your bundle. It's still going to be loaded. Now, it holds true that you wouldn't put sensitive data into your front end. Hopefully, you're not doing that. It belongs on the API. But if you do that, the code for your canActivate route is still in your application bundle, so it's actually still available to people once your app is downloaded. Now, canActivate child is similar to canActivate. It prevents unauthorized users from navigating to all children of a specific parent. And then canLoad is a little bit different from the other two because it prevents lazy loaded modules from downloading in the first place if the user is unauthorized to look at it. And the way a lot of this works is in our app routing module, when we set up our routes, we can use the interface name as the property for the guard that we want to add, and then we can give it an array, so we can pass it multiple guards. They're going to run in the order that they're listed. So if we just have something like an authentication guard that's going to check if the user's just logged in or not. As another note, guard files can implement multiple interfaces. So you can have an auth guard file that actually has a canActivate and a canLoad in it also. So you can use that sort of same file with the different interface types. But the canActivate guard in particular is going to have a canActivate function in it. And this function returns an observable, a promise, or a Boolean. So inside the guard, our canActivate function might contain something that looks like this. We can basically just say access is going to be denied based on some condition that we define. So maybe our authentication service has a method called isAuthenticated. It just returns true or false, depending on whether user is logged in or not. And if they are not authenticated, then we're going to return false and say this user, don't load this route. Now we could also take some action, like we could redirect the user to a login page, for example. And then we're going to return true if access to the route should be granted and navigation should be allowed to proceed. Now we can also do guarded lazy loading. And with this, we would use the canLoad route guard and asynchronously load sections of our application only for users that are authorized. Now, it's still true that you would never put sensitive data directly in your app bundles regardless. Sensitive data just doesn't belong in application bundles that end up being downloaded in a single page app. But with guarded lazy loading, we do get a few other advantages like smaller bundle sizes and some added protection. So if we come back to our app routing module, when we're setting up our routes, we are going to lazy load a routed module. In this example, I'm using like an admin module. So this might be several pages that should only be used and accessed by users with an admin level privilege. And then we can add a canLoad route guard. And in this case, I'm using a role guard. So this is a guard that could potentially be used for different roles. So I would be looking at for the role to be looking for admin specifically in this case, but I could have like an editor one, I could have a user one, so on and so forth. And we can also add route data that informs the guard what's expected. For example, we say, in order to access this page, we're going to use this role guard, and we want this person to have a role of admin in order to be allowed to proceed here. And we can do this with other guard types or any route-specific data. It's just nice if we want to do something that repurposes a little bit. So our auth role guard has a canLoad function in it, and this returns an observable, a promise, or a Boolean, similar to the other case. And our canLoad function might contain something that looks like this. So let's say that we're going to want to return an isAuthenticated observable. This observable is going to emit true if the user's logged in, and it's going to emit false if they're not. And then we can use the tap operator to execute a side effect. So we can say, if the user is not logged in, then the canLoad function is able to access segments, which is a URL tree. So this allows us to get the path of the guarded route, even though it's not actually in the bundle. And we can prompt the user to log in and then redirect back to the guarded lazy loaded route after they're logged in. Now, if the user is logged in, but they don't have the expected role, they're not the admin, then we can do something like send them to an unauthorized page. So coming back to our list, we learned about route guards and how we can use them and lazy loading to restrict access to certain routes. And essentially at this point, our Angular authentication to-do list is completed. So I hope that sort of in the last 47 minutes or so, I was able to demystify a lot of the complications around the standards and share with you some basics of authentication on the web. And there's a lot more to it than this. This was sort of what you would call the crash course version of it. And I also talked about how Angular provides things that let us work with authentication a little more easily. Now, the slides from the talk are available at this bit.ly link. And then also, if you are interested in learning quite a bit more in depth about identity in general, not just for browser-based applications, but also for mobile apps, for traditional web apps, as well as just a lot more history about the standards and how they came about, then you can check out this course. It's a Learn Identity series of videos from a principal architect at Auth0, and it's essentially the same training that Auth0 employees are given. It's publicly available. You don't even have to give up your email address or anything. It's just in the docs. So if you're interested in learning more, I highly recommend checking that out. It's pretty easy to digest. I am on Twitter, so if you have any questions, think of any questions later, have feedback about that quick start or anything like that, please chat with me on Twitter. And I really appreciate your time today. So thank you very much.